Hi students, today we will discuss about the Stokes theorem and the solved problems. So coming to the Stokes theorem, so it represents the relation between line integral and surface integral. So clearly Stokes theorem is the relation between a line integral and surface integral. So what is the relation between line integral and surface integral in Stokes theorem is, so the line integral along the curve C f bar dot dr bar equal to double integral over the surface S n cap dot curl f bar into ds. So this is the relation between line integral and surface integral. So the line integral along the curve C f bar dot dr bar equal to double integral over the surface n cap dot curl f bar dot into ds. Now coming to the problems, the first one is, so verify Stokes theorem for f bar equal to x square plus y square into I minus 2xy into j taken around the rectangle bounded by x equal to plus or minus a and y is from 0 to y equal to b. So this is the problem we need to evaluate now. So for the Stokes theorem, f bar is given x square plus y square into I minus 2x by j. So taken around the curve, which is a closed curve, which represented by x equal to plus or minus a and y equal to 0 to y equal to b. Now coming to the graph, x is from minus a to a, y is from 0 to b, so that we need both the positive x quadrant and the negative x. So y is only positive, so that clearly x is from minus a to plus a, so minus a plus a. So clearly x is minus a and here x equal to plus a, and then clearly x equal to minus a to x equal to plus a, so okay, final. Then y equal to 0 to y equal to b, so clearly x axis represents y equal to 0 and it is y equal to b, so that we have 4 points. The first one is minus a to 0 and the second one is a to 0 and this is a comma b and this is minus a comma b. Okay, so the direction, so simply anti-clockwise, so C1, C2, C3 and finally C4. So this is from the graph. Okay, now coming to the problem, what it has given. So by Stokes theorem, so line integral along the curve C of f bar dot dr bar equal to the double integral over the surface S of n cap dot curl f bar into ds. Now coming to the LHS, so the first one is f bar dot dr bar. Clearly r bar is what? Xi plus yj. Then what about dr bar? Dxi plus dyj. The derivative of r bar is what? Derivative of x plus derivative of y. From this, f bar dot dr bar equal to, we need to find f bar dot dr bar. So clearly what is given f bar? x square plus y square into I bar minus 2xyj dot dxi plus dyj. So dxi plus dyj. Clearly, so we need to find the dot product. I bar dot I bar is 1, so that it is x square plus y square into dx. I bar dot j bar is 0 in the vector product, so no need to take. J bar dot I bar also equal to 0, so no need to take. Then finally j bar dot j bar for the final one minus 2xy into dy. So f bar dot d bar is what? X square plus y square into dx minus 2xy into dy. Then we need to find the line integral along the curve f bar dot dr bar, which is line integral over the curve x square plus y square into dx. I have to replace f bar dot d bar with this one minus 2xy into dy. So we can evaluate this with a rectangle curve formed by these boundaries. So we have 4 curves, so along C1, along C2, along C3 and along C4, as like as in the Green's theorem. The first one is along C1. So along C1 we have the boundaries from minus a to 0 to a to 0, minus a comma 0 to a0. Since x is ranges from minus a to a, so x is ranges from minus a to a, but the y is ranges from 0 to 0, which means no change. Clearly y equal to 0, that means dy also equal to 0. So from this, x is ranges from minus a to a, so the bounds of x is what? Minus a to a. So that coming to the line integral, so the bounds are from minus a to a. Since y is 0, so that y is 0, x square plus 0 into dx minus dy is 0, since it is 0. Now, so clearly x square is an even function. X square is an even function, so that the boundaries from minus a to a can also be known as 2 integration of 0 to a x square dx, since x square is even. What is the meaning of even? If you substitute minus x here, minus x whole square also equal to x square, so that since it is even, so that the boundaries can be rewrite like this: 2 integration of 0 to a x square dx. So clearly x square, integration of x square is what? X cube by 3. The boundaries are 0 to a into 2. So substitute the upper boundary, which is 2a cube by 3. The first one along the curve C1. Now along the curve C2, so clearly along the curve C2, what are the changes? We have A0 to AB. So A0, so A0 to AB. Okay, so that, so clearly x is from a to a, no change. Y is from 0 to b. So if x is from a to a, which means what? X equal to a, no change. X is ranges from a to a, which is nothing but x equal to a. If no change in x, which means the derivative equal to 0, then the boundaries of y is 0 to b. Coming to the line integral 0 to b, x is what? A. So that, so we have x is what? A. So that it is a square plus y square into dx. Dx is what here? 0 minus x is what? A. So 2ay into dy. So clearly 0 into anything is what? 0. So that integration of 0 to b, so minus 2ay dy. So clearly minus 2a is a constant one, so put it outside. Integration of y is what? Y square by 2, and the boundaries are from 0 to b. Now 2 gets cancelled, minus a, substitute the upper boundary which is ab square. Then along C3. So along C3, what are the changes? AB to minus AB. So AB to, so minus AB. So clearly from this x is ranges from a to minus a, y is ranges from b to b. Since it is no change in y is ranges from b to b, no change in y, so that the differentiation is equal to 0. Clear the bounds of x is what? A to minus a, and coming to the integrand, what we have? So clearly dy is 0, so no need to take the second one, so minus a to a. So clearly x square plus y is what? B, so b square into dx. This is what we need to evaluate. So clearly x square plus b square is an even function. Even, so that we have to take the bounds like this. Sorry, and the before that, so here the bounds are from a to minus a, so that we need to change like this. So minus a to a. Why? Because so upper boundary having the negative term, so we have to transform a to minus a to minus a to a, so that we need to change. If we need to change, we can take minus x square plus b square into dx. Now x square plus b square is an even function, so that it is 2 integral of 0 to a x square plus b square into dx, so that minus 2 times of the derivative of, sorry, integration of x square is what? X cube by 3 plus b square is a constant. Integration of 1 is what? There is no constant, if it is treated as 1, so b square is a constant, put it outside, and integration of 1 is what? X, from 0 to a. Now substitute the boundaries, a cube by 3 plus ab square. Coming to the lower boundary, all gets zeros, so no need to take this, since it is minus 2a cube by 3 minus 2ab square. Okay, now along C4, finally along C4. So what about the C4? Minus AB to minus A0. So minus AB to minus A0. So clearly minus AB to minus A0. So that's minus A to A. X is ranges from minus A to A. So Y is ranges from B to 0. So there is a change in Y, but there is no change in X. So since it is minus A to A. Okay. So X equal to minus A. So that no change in X. That's why dx equal to 0. The bounds for Y is what? B to 0. So clearly from B to 0, X is what? Minus A. Now take X is what? Minus A. So substitute minus A here. So clearly X is minus A. So substitute minus A here, which is gives A square plus Y square into 0 minus 2 minus A Y dy. So minus and minus gets plus, so it is 0. So we need to interchange the boundaries from 0 to b, and then we get minus, and here minus and minus plus, so 2a y dy. So 2a is constant, minus, and for y integration is what? Y square by 2 the boundaries are from 0 to b. 2 gets cancelled. Now substitute the upper boundary here, minus ab square. So now the curves are over. Then coming to the final line integral along the curve C. So what is our value? So which is x square plus y square dx minus 2xy dy equal to summation of all four curves. The first one is, so 2a cube by 3, and the second one is what, minus ab square, and the third one is minus 2a cube by 3 minus 2ab square, minus 2a cube by 3 minus 2ab square. This is the third one, this is the second one, this is the first one, and finally the fourth one is minus ab square, the fourth one. So 2a cube by 3 minus 2a cube by 3 gets cancelled. The final answer is minus 4ab square. Now coming to the Stokes theorem, coming to the RHS. So what is our RHS? So LH is over. Then coming to the RHS, it is, so double integral over the region S. So the surface S, n cap dot curl f bar into ds. Now first thing is we need to find curl f bar. Curl f bar is what? It is equal to the determinant of I, j, k. So dou by dou x, dou by dou y, dou by dou z, p q r. P q r. So what is p? It is x square plus y square. What is q? It is minus 2xy. And what is r? So no r, no z term, so that since it is 0, we need to find the determinant. So that I, the first one is I, so that, so eliminate these two. If you want to find the product for I, cofactor for I, so then determinant of these two. So d by dy of 0 is what? 0 minus, clearly please observe this. So next one is this, d dou by dou z of 2xy. If you want to do the partial differentiation, if you want to differentiate with respect to z, treat xy as constant, and here we have minus 2 is a constant, so that the complete derivative of minus 2xy is 0. Why? Because treat minus 2xy as 0, so that it is 0. Next, minus j times of, so eliminate the jth row and jth column. Next, clearly see this, dou by dou x of 0, cross product, dou by dou x of 0 is what? 0 minus dou by dou z of x square plus y square. If you want to differentiate with respect to z, treat all this one as constants. So no z here, so that it is completely constant. Dou by dou z of x square plus y square is what? 0. Dou by dou z of x square plus y square is what? 0. Plus k times of, if you want to find the cofactor of k, we need to eliminate the row, entire row and entire column. The first one is, so here, dou by dou x of minus 2xy. So clearly dou by dou x of minus 2xy. So treat y as a constant and minus 2 as a constant. We have a differentiation for x only here. So minus 2y into, for x it is 1. Minus 2y into dou by dou x of x is what? 1. Minus, the first one is over. Next, dou by dou y of x square plus y square. If you want to differentiate with respect to y, treat x as constant, so that one should be 0 plus x square differentiation is 0. For y square it is 2y. This is the final one. So please observe this. If you want to differentiate with respect to y, so x square is 0 and for y square it is 2y. So this is we need to find. So it is 0, minus 2y, minus 4y k. This is the final value of curl f bar. Then, so since given value in terms of x and y's, so that n cap is equal to k. Why? Because given problem in terms of x and y, so that it is in the xy plane. In xy plane, n cap should be equal to k. So in xy plane, the normal of n cap equal to k. So we have curl f bar, that is minus 4yk, and n cap, it is equal to k. Then finally we need to find the double integral of n cap dot curl f bar into ds. So we need to evaluate this. So the double integral of, see, coming to the boundaries for x and y. So what are the boundaries for x and y? Clearly take the boundaries for x and y. So the boundaries of x is what? Minus a to a. So these are the boundaries of x, second integral. So coming to the boundaries of y, it is 0 to b. So y is from 0 to b. Okay. So x is from minus a to a and y is from 0 to b. So n cap is what? K bar dot curl f bar. Curl f bar is what? Minus 4yk into ds. So ds, under the surface, we need to integrate with respect to y first and then x, so that it is dy into dx. First one is with respect to y and the second one is with respect to x. Now k bar dot k bar is what? 1. What we get finally? Minus 4y. So that minus a to a, 0 to b. So minus 4y. So dy into dx. Take minus 4 constant outside. So minus 4. So minus a to a. So integration of y is what? Y square by 2. And the boundaries are from 0 to b dx. Now 2 ones are 2 2s gets cancelled. So minus 2 integration of minus a to a. Substitute the upper boundary is b square minus of lower boundary is 0, so that it is 0. So now I take this 0 dx. Now here b square is a constant, put it outside, minus 2b square integration of minus a to a 1 dx. For 1 it is x, integration of 1 is what? X, and the boundaries are from minus a to a. So clearly minus 2b square a minus of minus a. Upper boundary is a, lower boundary is minus a. So minus 2b square into a plus a is what? 2a. Clearly minus 4ab square. Since, so what is our LHS? Minus 4ab square. What is our RHS? Minus 4ab square. So clearly LHS is equal to RHS, since Stokes theorem is verified. Okay students, thank you.